Let's take the world you see every day, the cars, the people, all that blur of motion, and let's just slow it down. I mean, way, way down. We're about to take a little trip into the moments that happen between the ticks of a clock, right into the world of the millisecond.
So here's the big question, right? What can really happen in a thousandth of a second? It sounds like nothing, just a meaningless little sliver of time. But it turns out that tiny little fraction of a moment is absolutely jam-packed with action, and we're about to see just how much.
But hang on, before we dive into the super fast stuff, we need a little bit of perspective. Because this modern obsession we have with slicing time into these tiny, tiny pieces, well, historically speaking, it's brand new. For most of human history, time was a much more relaxed thing.
I mean, think about it. Ancient clocks were sundials. Your day was measured by shadows, not minutes. The whole idea of a minute was just too small, too fussy to even bother with, until the minute hand finally showed up on clocks in the 1700s. And the second hand that we see everywhere today, it's only been common for about 150 years. So what I'm getting at is, we've only just recently learned how to trap time in these tiny little cages.
Okay, history lesson over. Let's hit the accelerator. We are leaving the slow world of seconds way behind us, and we're diving headfirst into the millisecond. You're about to see just how different the universe looks when you start measuring it in thousandths of a second.
So let's start with something big and heavy, like a train. In just one single millisecond, that massive machine moves a mere 3 centimeters. Yeah, that's about the width of your thumb. It sounds pretty slow, right? Oh, just you wait.
In that exact same millisecond, the sound of that train's whistle, it travels 33 centimeters. That's 10 times further. So we've gone from the width of a thumb to about the length of a school ruler, all in the same instant. You see how the scale is already starting to shift?
Okay, now let's level up to a plane. In that same tiny sliver of time, it covers half a meter. We're now measuring the world in arm's lengths, and we are still inside that single, completely imperceptible millisecond.
And here is where it gets truly mind-bending. Light. In 1 millisecond, a beam of light blazes across 300 kilometers. That is roughly the distance from New York City to Boston. An entire road trip, done, in a slice of time so short your brain can't even register that it happened.
All right, let's bring it back from those cosmic speeds to something a little more, well, annoying. That buzzing mosquito by your ear, it flaps its wings about 500 times a second. So for that little pest, a millisecond isn't some abstract idea. No, it's a fundamental unit of work. It's enough time to power one full stroke of its wings. We like to think of ourselves as pretty quick. And what's the fastest thing we do without even thinking about it? Blinking. We even have phrases built around its incredible speed. But when we put our own fastest action under the millisecond microscope, well, it turns out to be a surprisingly lazy, drawn-out process. You've heard it a million times, right? It happened in the twinkling of an eye. It means something happens in an instant. But what if I told you that the twinkling of an eye is actually an eternity compared to what we've just been looking at? Okay, get ready for this. The average blink takes 400 milliseconds. That's nearly half a second. It's not a flash, it's practically a slow-motion event. It's 400 times longer than it took that beam of light to get from New York to Boston. And you know what? It gets even stranger. Because get this, a blink isn't one single motion, it's 3. First, your eyelid falls, which takes about 90 milliseconds. Then, and this is the wild part, it just stops. It actually rests at the bottom for up to 170 milliseconds before it even thinks about going back up. Our fastest reflex has a built-in coffee break.
So what would the world actually feel like if we could perceive things at this time scale? If our brains could process reality millisecond by millisecond. It's a crazy thought experiment, and thankfully, the legendary H.G. Wells already took us there in his fantastic story, The New Accelerator.
In his story, the characters take a drug that speeds up their perception so much that the world around them just stops. I mean, imagine looking at a curtain that's supposed to be flapping in the wind, but instead it's just hanging there, perfectly still, caught in a single frame of its own movement.
It becomes a world of living statues. You could walk down the street and see a cyclist just frozen in place, with a little puff of dust hanging motionless in the air right behind their tire. Motion, as we know it, has just ceased to exist. You'd be walking through a photograph of a single instant. So here's the breakdown. Our reality is this symphony of motion and wind and noise. Theirs, it's one of absolute silence and stillness.
They've literally entered a hidden dimension that exists between the ticks of the clock, a world that is always there, but completely invisible to us. Okay, so H.G. Wells was writing science fiction, but this whole quest to perceive smaller and smaller slices of time, that is pure science fact. So let's leave his story behind for a second and see just how far we've actually pushed our ability to measure these impossibly small moments.
A millisecond seems fast, right? But to a physicist today, a millisecond is an eternity. They can now measure time in intervals as short as 100,000 millionth of a second. The number is so small, it almost loses all meaning, so let's try to give it some.
Here is probably the most stunning comparison I can give you. A nanosecond, which, by the way, is 1,000,000 times longer than the shortest time we can measure, has the same relationship to 1 second as 1 second does to nearly 3,000 years. Just let that sink in for a moment. The entire rise and fall of ancient Rome is to us what a single second is to the world of nanophysics. And that really brings us to our final thought. From the lazy little nap in the middle of a blink to the universe of action inside a mosquito's wing beat, there's this whole other layer of reality that's just moving too fast for us to see. It really makes you wonder, if we could tune our senses to those incredible speeds, what other fundamental secrets of the universe are just waiting to be seen right there in the gaps between the seconds?